Hello, my name is Rahal, and this is my group's Lab 5 video. So, I'm going to start really simple, just uh, adding the airfoils we need, the 4412 and the 0012, in using the NACA database that is built into XFLR5. And we're also going to change the color and line width of these so it's very easy to see, very easy to tell what's going on with each of them. And I'm going to add more panels to this 0012 just for a little more precision since it is symmetrical and easier for the program. Now we're going to move into direct analysis for the airfoils, and we're going to get our graphs, CL alpha, CD alpha, CLCD alpha, and CLCD all already on there. So we're going to start by defining an analysis. We are going to input the Reynolds number and the Mach number at 30 hertz within the wind tunnel, which came out after some calculation to be 49666. And the Mach number came out to be about 0.021. We click OK. That created an analysis for the 0012, and we're going to do the same thing for the 4412. And then we're going to analyze each of them. And perfect, some graphs pop up. And there we go. That's our 30 hertz graphs for both of our airfoils. Here's each of them individually. Now we're going to do the same thing over again, but we're going to modify the conditions to a 60 hertz. I'm going to select the 0012, and we're going to move up the Reynolds number to 101,935. And then the Mach number is going up to 0.043. And other than that, it's the same thing for each foil, and we will analyze both of them. And there we go. That's one, and that's two. So another comparison, here's each of them individually. And that is our entire airfoil analysis. All of that data is very easily exported by right-clicking on the graphs, but now we need to modify the analysis. We're doing a batch analysis now for both of the airfoils at Reynolds numbers of increments of 10,000 from 40,000 to 150,000. This will come in handy later when we are working on the wings because the wing analysis needs values to interpolate between, and this is where it'll pull that data from. So we let this go. Now that it's finished, you'll see a bunch of different lines pop up for each one. And that's perfect. Now we will move on to the wing analysis. So we're going to start by immediately deselecting the elevator and the fin options because those are not necessary for what we are doing. Going to name this the 4412 wing just so it's very easily recognized. So I changed the chord to 0.1. Oops. All right, move this offset off so we just have a straight wing. And then we're going to change the wing length to 0.075. All of these measurements are based off of the wing that we used in the lab. Now we just select the foil as 4412 for both the center and the ends. You can check these specs right here to confirm, and just for consistency, we'll change it to the same color as before and save. Now we will do the exact same process for the 0012 foil. Deselect the elevator and fin, and name it the same way. And add the same measurements. The only thing that'll change here is the foil being used. Other than that, everything's the exact same. Perfect. And change the color for consistency once more. All right, now we move on to the analysis portion. So we're going to define an analysis. We are going to use that speed right there is the speed that we calculated for 30 hertz in the wind tunnel. And we are going to use horseshoe vortex and not LLT because the LLT does not work properly. So as you can see, it worked. We have a little animation here showing the different things going on at each angle of attack: downwash, viscous drag, induced drag, pressure and lift. All of it's here. And now we're going to do the same thing for the 4412. Here are the graphs though for the 0012 on its own. So now we're going to run the same analysis. And we can see all the same things. And we're going to look at the graphs. We'll change the line weight and color just to match what we had before and make it clear which one we're looking at each time. So we got all of the same graphs we had before for the airfoils, just now for the wings. And here's each of them on their own. And now we will repeat the same process, but using the 60 hertz airspeed that we calculated should be 14.56, I believe. And same analysis as before. And we get these graphs. And that is the whole thing. It's pretty much the whole analysis. Here's each of them individually. And yep, thank you.